When we run commands at the bash prompt interactively, we typically run a command, check its output, and get our next prompt so we can put our next command in. For example, if I wanted to see what my files were, I could do an ls command. I put in my command, I press enter, it runs the command and gives me output, and I get my next prompt on a new line by itself so I can see it's ready for the next command. If I wanted to know how many files I had instead of their names, I might have taken the output of ls and sent it through a pipe so I get just one file per line, and running that to a command like wc-l to count the lines. And I would see I had 15 files. This is fine if I'm just running these commands myself. I know what commands I ran and why, and I know what that number means. It means there's 15 files in the current directory. If this was output from a script, the person using the script has no idea what commands got run. All they see is 15, which doesn't mean anything to them. So normally when we make output like this, we attach some kind of a label to it. We put a definition on it so the user knows what it means. We might first use something like an echo command to print out the label for it. Then run the command that generates the count, and we get our output. Now, if our output came out of our script as number of files and a prompt and a number, that would be very confusing to the user. Even if we were to put those two commands together to run all at once, again, we'd still have a prompt and then the number on separate lines, also not ideal. Get all nice on a single line of output and then ask us for the next prompt. Okay, so we need a way to put more than one command on the line. In bash, this is known as creating a command list. So a command list technically can have just one command in, but normally it has more than one if we're calling it a list. The way that we put multiple commands on a line is we put the first command, then some kind of an indicator to bash that there's going to be another command. It's called an operator. And then we put the next command. And if we could put another operator, and another command, another operator, and another command, and we can make it as long as we would like to make it. The first operator we will look at is the semicolon. So the operator not only separates the two commands on the line, it also tells bash the rules for how to run the two commands. So semicolon will separate them, and the rule it gives bash is run the first command, and when it finishes, no matter whether it worked or not, what it did, what it didn't do, it doesn't make any difference, then run the next command, and so on for as many as there are on the line. So if I wanted to run my command to print out my label, then run my command that prints out the number, all in one go, I could do the first command, semicolon, the second command. And it will run the first one and then immediately run the next one. This cleans up my output somewhat. It means that my commands run together without waiting for input from me. That's good. However, I still have this problem that my label and my data are not on the same line. Maybe that's what you want, maybe it's not. There is an option for echo that lets us put them on the same line. The reason they're not on the same line is that echo by default prints out an empty new line character at the end of its output so that our prompt or whatever comes out next is on a second separate line. N, no new line it means. So now when we print our prompt, it will come out. The text output will stay at the end of the word file, and then the next command will run. So our outputs will run together. This still doesn't look the greatest because I really needed to allow some space between them, and I did not. The easy way to fix that is go into my prompt and add a space at the end, whatever spacing I would like to have. So that's part of my label. And now it looks much nicer. This is a very common technique. There are 3 examples on the slide that you can certainly try. The first one is very similar to what we've just done in this video. The second one will count up processes by user that are running on your system. The third one will tell you the IP address of your Ethernet interface. assuming you have one. It assumes your interface is named EN01. If you're actually running on VMware, the interface name you will likely be using is called ENS33, and you should use that instead of EN01 on that line. If you're in VirtualBox, your interface name will be ENP0S3, and you should use that instead of EN01 on that line. Go ahead and try those now.